Good evening, everyone. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Free Energy Friday. Welcome to the show. It is July 3rd, 2026, and Canada just celebrated its 159th birthday on Wednesday, July 1st, and our brothers to the south, it's Memorial Day weekend. July 4th is tomorrow, so happy Independence Day to our American listeners. And we're probably not going to see Lulu tonight. She has some family stuff she has to deal with. So hopefully we'll see her next week. But the show goes on. I know it's Memorial Day weekend. A lot of people took Friday off in the States. We had some issues with our machinery again. It's been a shit show all week with our machines breaking down at work. And a lot of our tech support is in the US, and we had an issue with our laser cutting machine and tried to get tech support, but it seemed like all the companies that we deal with in the US were all shut down today. So we weren't able to get the tech support we needed. So we closed up shop early today. We got out of work at like 2 o'clock today because all our freaking machines are broken. So it seems like a never-ending thing, but that's
pretty funny. It's like Murphy's Law. What you don't want to happen will happen, and all your machine broke the day that the people the support was.
It's just kind of been an ongoing thing because a lot of our machinery is getting a little bit old, right? And I don't know how long this owner is going to keep this shop running, with all the machines falling apart all the time. Right? Like his costs are just enormous to run a business now like that. His rent is like doubled in price. And, you can imagine all the maintenance costs and hydro and, everything to run a business. The costs are just enormous now. So it's like for a small business owner in Canada, it is very difficult to run a business and see, half decent profit margins. But anyways, live chat is open. Good evening, chat. Welcome. Any questions, comments for myself and Philip, please do so in the live chat. If you're on YouTube and you're watching it right from the Faraday Research YouTube channel, you could also send me super chats to help support my channel and support my experiments. So I've been doing continuous work on the power cell. I did a new reiteration of my power cell technology, getting it down to the point now where I can't really go any better because it has to do with the fabrication. Would have to be stepped up exponentially to more industrial because building the layers inside a power cell like I'm doing require very expensive lamination machines to do that. So, but as far as the electrochemistry, I've got something going that is actually very, very good, very promising as far as energy density, power output, also the footprint, how many milliamp hours I can generate in a 24-hour period. I was putting some numbers through AI, and it was giving me some interesting results, saying that I've possibly have created a room temperature superconductor. So if it's correct and the data that I've given is correct, I got something pretty special going there. So I'm going to stay with that. Hopefully things will come to me down the road where I'll be able to get, a hold of, some better fabrication methods. We'll see how it goes. But as always, we got Philip on with me here from Montreal. Hopefully I sent a...
Gatineau, actually. Gatineau.
Oh, you're in Gatineau now. Yeah, that's right. You moved back home.
Yeah.
So, hopefully I sent an invite to which we call Gerald. So maybe possibly he might jump on. and also Elijah too, if you're free and you want to join the conversation. And also, I gave an invite out to Mr. Jarvis, so hopefully he might show up tonight. I know it's Memorial Day weekend. A lot of people, buggered off for the weekend. They,
Independence Day
weekend.
weekend, not
Yeah,
Memorial.
Independence Day, or sorry, Independence Day. My mistake. So yeah. So I know, Philip, you got a presentation for us. So I guess we'll start with that, and we'll kind of go from there.
Okay, yeah. Once again, it's another historical presentation tonight.
Cool.
Yeah. All right. So, and I'm into your field now, which is power generation and things like that. So, I'm not gonna share the secret sauce, but this week I've been working on a way to amplify the output power of a laser, and that laser, the laser can be a visible frequency laser, or RF laser, or X-ray laser that can go through matter, or any other type of laser that can penetrate matter, because I can use it for tractor beams to generate a force that can be used to pull or push objects remotely, even through metal. Actually, if I was to use RF lasers, um, the energy could go through metal, because I don't want the beam to be reflected. So, anyways, I found a way to. It's very confusing. It's to work on that, but I debated with AI all week long. I even since July 1st, we were able to upgrade to Fable, Claude Fable 5. So it's a little bit more powerful than Opus. So I use Claude Fable. I argued with it a little bit, um, but um, turns out I am the one with the last word, because I was confused myself as well, but unconsciously I knew what I had to do. So I found a way to, suppose you have a laser with requiring 1,000 watts of input power, then I know how to generate 1 terawatts of output power from that laser. And the power is a time derivative of energy distribution, but the space derivative of energy distribution is a force. So power and force are the same thing. They're just that power is derived over time, and force is derived over space. So that's why I'm saying it can be used as a tractor beam, which is pretty awesome. And I don't create or destroy energy here. I'm just amplifying the power, which is different than energy. So it's perfectly legal to do that. I don't invent anything, but technically you can generate an arbitrary force, infinite force, as a matter of fact. So it's pretty awesome. I'm really happy about that. Um, I always had that unconsciously, but now I have mathematical evidence. And also the really funny thing is, I was using, like I was saying, Claude Fable, and down the road, right before the show, Fable decided that what I was doing is not secure, and my research is flagged. So so they're gonna review my research, because they apparently what I'm doing is a national security type of level, type of research.
National security. Fill up the national security risk.
But here's the proof. You can read the message yourself. Was safeguards flagged, so it's pretty funny. So yeah, that's what I want to share. It's pretty short presentation, but it has a lot of weight and it's pretty valuable. And yeah, I'm pretty happy about that. Sorry, I cannot share the secret sauce.
Yeah. Yeah, well, that's fine. Yeah, that's we get that. Elijah, thanks a lot for joining us. We need your expertise.
Yeah, yeah, thanks for having me. I was a little bit late because I found some like rodents in my car, so I was dealing with that last minute.
Oh, jeez. Do you have like a field mice problem there? I know you live kind of in the woods a bit.
There was like a rat making a nest in my cold air intake of my truck, and then in my car, I popped my hood up, and like right next to my fuel pump, like in the corner, it was making a nest on the frame, and there was like I think it's like a ground squirrel. I don't actually know, but
yeah,
those
I know. I know we have problems with that with squirrels here, especially when it gets colder out. What they'll like to do is jump inside the engine compartment of your car in the winter time, because after the engine's warm, you know, it keeps them warm, right? So they'll jump inside the engine compartment and just sleep there for the night. So yeah, that's not uncommon.
Yeah. So luckily it didn't cause any problems yet, and I just put some like repellent stuff in it and burned their nest.
Yeah. That or have a couple of cats running around.
I do have cats. There was 2 field mice today. I popped out of the trailer, out of the door, and right next to the door there's 2 dead mice. So
yeah.
it's working.
Yeah, right on. Cool. Yeah, so
So Elijah, did you understand a little bit my little presentation?
I understood what you were saying, but I don't know how or the mechanism, like how you make a laser have more power output, and if it's like, is it just the force of the photons pushing, or is it actually something more than that, like Tom Bearden's scalar interferometer, to where it's actually going down to the mass of the object and affecting its inertia?
Yeah, actually, the power again is I'm amplifying the power, not the energy, and the power is the derivative of energy, and with some sort of modulation, I'm able to maximize I'm able to amplify the resulting power. So it's pure mathematics. And I was confused a lot myself this week, but it all makes sense. And but yeah, now I'm gonna present that to well, I already submitted it to ONR, Office of Naval Research, but I can submit it to DARPA as well.
Speaking of lasers, remember you were Elijah, you were talking to me about exposing my cells to laser.
Yeah, I was thinking like maybe your power cells are kind of like a Peltier
Peltier device. Yeah.
Yeah. So thermovoltaic, basically. And I was thinking that could be happening, and it could even be amplified if you put phosphorus on one side of your sodium metasilicate, so it acts like an NP junction.
Right. It's kind of funny you mentioned that, because what happened was last weekend I met up with a buddy of mine that lives in the town next to me, and every now and then he'll get me some materials. So he got me germanium in the metal form, like just a little vial like this. It was like $45 Canadian. So he got me some real germanium metal flakes, so I can test that. And also, he got me an infrared laser. I didn't even know
Oh,
he was
nice.
giving it to me, so he ordered me an infrared
Cool.
laser.
I could use it for my tractor beam.
So, so the infrared laser, I was thinking of actually exposing the laser light to my layers after I've set them. Would that change the chemical properties of the carbon and iodine? And if I were to expose it to an infrared laser, do you think there might be any kind of benefit with that?
I don't know if it would change the carbon, but I think it would change the metasilicate. Any sodium metasilicate or uh, uh, polyacrylate. I think it
Yeah.
would kind
Yeah.
of organize those into like crystalline layers that are almost like how you can cool a gas with a laser. I would guess that as
Yeah.
the thing is going from liquid to solid, it would slow down the rate at which it cools with the infrared light on the surface, and you would
Oh,
get like a gradient at which the surface cools a lot slower than somewhere deeper in it, and you would
right.
get like a more crystalline structure on the surface that would actually have layers that would stack with the light beam in the
Right.
way it's refracting.
Oh, in the way. Oh, I see
And
what you're
so
saying.
it would
So,
be
due
like
to
more amorphous.
right. So, like the nanometer frequency is in layers, basically. So, what you're saying for every layer of my electrolyte, that laser will cure it at a certain gradient relative to the next phase down, kind
Yeah,
of
like
thing.
you have the light scattering, and then you have the infrared light being absorbed as well. And so the surface layer will be heated by that laser, and so it'll cool the slowest rate. And so that surface
Right.
layer, where it's making contact initially,
Right.
will probably become the most crystalline section of that material. And as you
Okay.
go deeper in that layer, it'll cool faster and you'll get slowly a more amorphous structure. So the amorphous part will be like more of a broadband amplifier where the bond angles are very different. And then as
Right.
you go up, it'd be like an impedance matching zone for like a silicon carbide layer if you were using like a
Yeah.
metasilicate, for example,
Right.
into the activated carbon layer after that. So you would have better impedance matching, if that makes
Right.
sense.
Yeah.
But
Yeah.
I don't know if that's what would help or not. But I
Yeah,
do
like I've
that.
like I'm not using the polyacrylate anymore. That was
Okay.
another version of the cell, but I am using silicate carbide in the electrolyte solid state. So hopefully the laser might be able to do something with the crystallization process of that. So I've been reading up on how to create the polymer chains that allow the ion flow from the magnesium anode through that matrix. It's like kind of like okay, like veins going through an electrolyte. These vein galleries, and they're all wrapped around and bonded crystal, like a crystal structure bonds around these channels. And these channels is what allows the magnesium ion flow through the matrix, right? So the biggest hurdle with pretty much anybody who's worked with a magnesium cell is magnesium ions because they got two charged protons going through. It's twice as energy dense as say lithium, so you get the sluggish effect. Now, my cell that I did last week, literally my layers of everything that makes the cell run is literally painted on. So we're talking like 30 nanometer layers. So I'm right up there with some of the top battery manufacturers as far as layer thickness. So like I'm getting consistent two to 3.5 amps of current coming out of it, and I'm sustaining voltages between 2.5 and 3.5 volts. Um, I could do a charge on them for like 20 seconds, and it'll get it up to about 4.5 volts. and I could run a 3-volt LED that draws 20 milliamps. I could run it for 48 hours on it. So based on that information, I fed that into ChatGPT, and it says I'm approximately getting 960 milliamp hours out of this little cell. So now the thing is, I know it will run a lot longer. And it says if it is running longer than that, you might have possibly created a room temperature semiconductor, because of the fact that it only takes 20 to 30 seconds to charge this, and then you could get 3 days life out of it. So they say very possible that you're on the cusp of creating a room temperature superconductor. So
What I would try if you're running tests with an LED with runtimes is temperature control the room to the same temperature, and
Right.
then try that runtime with the lights on versus the lights off, and see if the battery changes temperature versus one versus the other.
Yeah.
So like if one is colder, like if when you have the lights on and it's colder than versus when the lights are off.
Yeah. No, it does have some thermoelectric properties there. There is a small degree, like I've done other projects where I get a greater degree of temperature variation between the anode and cathode. And I know if I do heat it up, the power output does increase. So there is a thermoelectric component to it. Now, I'm really curious to see if there's any kind of photonic reactions if I expose it to sunlight or ultraviolet. So now I got that UV laser. I can do experiments with that UV laser and see if that changes anything, heat or light or voltage. So be interesting.
Yeah. So sorry, I forgot to say that the power amplification I was talking about earlier can be converted into electricity using a voltaic cells.
Yeah.
And so it's kind of a free energy right there,
It is. Everybody kind of underestimates solar. Solar is free energy. It is, because you're getting it from sun, and the sun lasts for 4.5, 13 billion years or whatever it's been alive for. So you got hydro, you got solar, you got geothermal. Those are all free energies. So we have hydro,
but
only high.
I mean, using my tractor beam, I could aim for these photovoltaic cells and create, amplify the electricity as well. So I can amplify the power, which consequently will amplify the generation of electricity. So you got competition now, Mike.
It's okay. It's all good.
Regarding the lasers you're talking about, I'm interested into lasers that can the like invisible lasers, like they can go through matter and this and that, because I don't want a laser to be reflected, especially not by metal, because most of the projectiles are made out of metal. So I need a laser able to penetrate any material. So I did a little research, and apparently there are RF microwave deep penetration of the dielectrics, terahertz semi-penetrating, and X-ray deepest penetration. So if I had X-ray lasers, that would be the most efficient way to penetrate matter.
Oh, sorry to cut you off. The guy that gave me the laser and the germanium, he's also got some crazy ass World War II radio spark gaps. I think they're from radar countermeasure devices. these spark gaps are the wildest freaking things I've ever seen. Like they look like they're alien. That's how weird these things are. He's ordered them. Hopefully, we'll get it probably in the next week or so, and I might be able to show off these crazy spark gaps. Like I already got a little inventory of some World War II Navy spark gaps from their radar systems. So I've got a pretty cool collection already. But these new ones, oh man, these are so funky looking. Oh, they got like
Nice.
they almost stuff that what's his name? Farnsworth, the guy who invented the television. He was working on some fusion technology before he invented the TV. And these spark gaps look like what he was making back around 1920. So I'm really eager to get my hands on these new spark gaps. They're like awesome. They look really cool.
That's really interesting you say that, because there's a good connection here through Thomas E. Bearden between what Phil is saying and what you're saying, Mike, and like that you just kind of connected the dots. So I was watching Thomas E. Bearden lecture about weather modification, weather warfare from the Russians, and he was talking about Nikola Tesla's death ray is two radars that are converted with, he says, a 10-cent part to change it to basically a scalar radar, a sort of interferometer, if you will, and you put two of those and you shoot it at the same spot somewhere.
Right.
You can get all sorts of different anomalous effects, from Phil's effects of pushing something, pulling something, to basically altering the weather with charge and stuff like that. But I'm thinking about the spark gap. And
so this is creating scalar waves.
Yeah, so you mentioned the spark gap, and that just kind of connected something for me. What if the spark gap is creating the implosion and explosion for the scalar component? Because people kind of say that, oh well, it's static electric, but it's more than static electricity, because how can static electricity form if like charges repel, right? So that tells me that it's going through the matter to the nucleus, just like what Phil's trying to do is go through matter, right? So like if X-rays are not so good because they only go to the orbital level of an atom because of its band gap, right? So if you want to go to the nuclear level, you need gamma rays or higher on a photonic scale. But once you get to an oscillation of the ether imploding and exploding, you can go straight to the nucleus and through the nucleus like a phonon instead of a photon. And I believe that's like the time reversed wave component, so there's forward waves and backward waves, and both are going simultaneously.
Yeah,
and
it's like an echo, right?
Yeah, I think it's like a harmonic oscillator where it's these harmonics of standing waves that form out in space based off of the situation, whatever's going on, because everything's made out of light, and so everything is a harmonic of light. And
so
I'm thinking
by phonons you mean the sound?
No, I mean like so the not the photon itself that kind of travels in between the matter, but the part that travels through the nucleus. So the photons kind of travel through the void, whereas the phonon travels through the matter itself because the matter is light. So it's modulating the way the light is interacting with matter.
Wouldn't that be like the heavy side component, the electrostatic potentials that are forming between?
I think it's more than the heavy side component, because you need some sort of oscillation. You need a implosion and then an explosion, and it to be cyclical. Otherwise, you don't really have the right energy flow. because I know with the heavy side component, you take a mechanical switch, even with that switch off, if it has voltage applied to it, energy will flow through it if you apply displacement current density, which is just dipole flipping. Energy will flow through that switch. And just like someone just said, that A vector, so that B vector can be 0, but the A vector is still present. And so energy can still flow. So I think, the heavy side component has something to do with
Now,
a
like
parametric oscillator working, but it's
yeah,
not the whole thing.
Yeah, like Eric Dollard was talking about free energy with Peter Lindemann a little while back, actually not that long ago, a couple months ago. And he says he's not big on free energy, but he says if he were to put his money on a free energy device, it'd be electrostatic. It'd be like the Trump motor or the Trump generator that Donald Trump's great uncle made back in the 1920s, 1930s. That was a free energy device because he says electrostatic, as soon as it's created, it stays kind of like an electric. Okay. And if there's any other electrostatic component nearby, it will actually gain power. So it's one of those things where, you would think it's kind of breaking the law of thermodynamics as far as creating energy. But if it's able to harness electrostatic fields that are present around it, not only itself, it's electrostatic, those potentials start rising. So when, what's his name? He was an inventor back in the early 2000s. What's his name? It's on the tip of my tongue. But anyways, he made a rotary, basically electrostatic generator. So it spun these, those old variable capacitors, when you spin them, they get different inductance and all that. Well, he got one about, I would say about 2.5 feet long in segments, and he put a motor to it and spun that motor up to a high RPM. It created electrostatic potential. So it was electrostatic oscillation converter. So it was bumping back and forth from one side to the other, back and forth, and then you take that power and dump it into a capacitor bank, and you got energy out of it. So, he actually took his device after that's his name, Chris Carson. He did actually a live lecture with Eric Dollard. It's on YouTube. You can watch it. Chris Carson and Eric Dollard. He's the guy who made this electrostatic motor, and he finished it and he signed off on it around 2000, and he died a few years later. He died of cancer. But anyways, he has his device, and he actually got it going and ran some really good diagnostic tests on it, and he says it is over Unity. So there's an example. Now the Trump motor is kind of based on the same thing, just in a different, setup, the way he had it set up. So apparently Dollard and Aaron Murakami want to rebuild this device. So I'm kind of going to the site every now and then and seeing if they're actually started building it. Would be really cool to see what they would come up with, the Trump motor.
Who's his highness again? He's
His highness? Oh, he's a regular. I don't know his.
I thought it was somebody everybody knew.
No, he's here every weekend. He's one of our religious followers of the show.
Yeah, because he's saying
his real name.
He's saying he saw a tractor beam used by a saucer and they were towing something. So it's pretty cool.
Yeah, I kind of seen something similar like that back on the 4th of July in 2013, around 3 o'clock in the morning. Yeah, it was one of my UFO sightings. That night pretty much made me a believer. I haven't never seen anything like that in my entire life.
He was towing something?
No, there were basically about six of them, just kind of materialized out of nowhere. They were above the cloud line. They were not drones. There were red light and green lights chasing each other, and it looked like they were in some kind of fight, and they were actually shooting lasers at each other.
Ouais.
They would go from basically the northern hemisphere to the southern hemisphere within seconds, like they were traveling that fast.
OK.
Stopping on a dime, making a left-hand turn, turning 90 degrees on the spot.
You saw them in Toronto?
This, yeah, in Toronto, about 3 o'clock in the morning, and this whole event went for about 10 minutes. I'm watching this fight above my head, and one of them was shooting a laser at the other one, and I knew it was real. Know why? Because when he shot the laser, I saw the reflection off the clouds behind it,
OK.
of the light being emitted from the laser behind it. It was hitting the cloud. I was seeing the residual reflection of the laser light against the clouds. I
Yeah.
knew it was real. When I seen this, I'm like, what the heck is going on here? To this day, I haven't seen a sighting quite like this one. This one was like,
You didn't take pictures or anything?
no, back in 2013, the cell phones didn't have a good video at that time.
OK.
2013, they weren't that great. You know, the iPhone was just kind of getting off the ground, right? So
Yeah.
I didn't really have a good way of making a video. And plus, it was far away too, right? It was above the cloud line. I would say above 40,000 feet. That's why I knew it wasn't a drone.
Yeah, it's funny. It's funny. I never. I hear a lot of people saying like are witnesses of UFOs, but myself, I never saw any, and it's like it's pretty funny. I'm not like angry, but I just kind of say it's kind
Yeah.
of funny, you know.
I've been lucky to see 3 pretty good events in my life.
Yeah, cool.
3 pretty interesting. Yeah, that one on July 4th, 2013 was the one that pretty much made me a believer that something's going on.
Okay.
So, yeah, either if
Ouais.
it's ours or somebody
No,
else's, I don't know. But
no,
all
no,
I know
no.
is I seen what I seen, and I know it's real.
Not to
And it
mention,
wasn't drones.
not to mention the orbs that constantly harass you.
Well, no, they're just in a different light spectrum. That's why I can't see them with the naked eye, right? They're either above 650 nanometer or below 350 nanometer. So, our visual spectrum's about that big,
Yeah.
what we can actually visibly see. That's why when I take pictures of the sky, when I got some of my experiments going, I pick up these orbs, they pop up because my camera can pick it up because of the nanometer frequency that I can pick up with the camera on the cell phone. My eyes can't see it, but my cell phone can.
Okay.
And it's not lens flares. It's not anything like that at all. Like I could have the sun behind me and catch an orb in front of me. So there is no lens flare, but it is refracting some kind of light from that object, right? So I don't know. Believe what you want to believe, but I know what I've witnessed and seen. So
Yeah, I don't have any doubts that they're real because I've experienced it more times than fingers I have. And some were with other people. A lot of them were with other people, and some were by myself. And some were responding to my thoughts. And sometimes they seem to be just watching you. And if you look on Brucey's channel on YouTube, you can see the UFOs having battles like you're describing. And Bruce Swartz also died, they say, of a heart attack. I don't really believe that. And like you were saying, that guy who made the parametric generator, the variable capacitance one, he died of cancer. That kind of reminds me of James Allen, the guy who made the documentary of Mark McCandlish and the Fluxliner. He was given cancer. You could say he died of cancer, but he was really murdered. So
he was knocked off for sure.
But going back to detecting them, you can detect them in infrared light because on Brucey's alt channel,
Yeah.
he had an infrared light telescope. And then also what you can do is like these motionless electromagnetic generators, they actually can pick up on gravity waves, I think, or that's my interpretation, or the movement of like
what kind of
objects.
device?
What's that?
What kind of electro? Okay, so you got a core and you got two coils.
Yeah, so like this is the same meg I used in my 5-day run time experiment with
Okay.
the Benin motor that just wouldn't stop running.
Okay. Okay.
And I have a central smaller winding in the center as well. That's 100 reps, but it's a lot smaller. But I
This is
have
what's the
a
gauge
video on
wire?
this where I have it hooked up to an Arduino, and it's printing out on my computer screen from the Arduino a graph in live time. And it was picking up people walking down the hallway. It was picking up me just punching at it. And it's
Really?
able to pick up these craft that are flying around.
Now, question for you on that coil setup. What gauge wire are you using? It looks pretty thick.
I took it out of
60 gauge?
one of those single phase transformers, and just looking at it, it kind of looks like 10 or 12.
10 or 12 gauge. Yeah, that would probably be, yeah. So
And
quite thick.
this is 1 inch by 1 inch laminated iron core,
Right.
and it's about
So-
100 watts on either side, and they're both equal lengths with each other.
So
And-
do you hook that up to an oscilloscope, and that's where you see the frequency bouncing around?
No, I was actually basically that center coil. I was measuring that center coil with power and voltage, because I was also doing pulse width modulation experiments on the center coil and seeing what that did on the output coils.
Right.
And I think it's utilizing some sort of Aronoff bomb effect to detect
Right.
basically, I don't know if I call it gravity waves or electrostatics or what, but some sort of, it's detecting
Electromagnetic
something
interference?
in the form of real actual power.
So how about radio?
It's not picking up radio waves because there's no noise from the radio. It's like if I did this and I punched towards it, it would
It
have
reacts.
a spike and pick that up. Yeah, exactly.
Okay, so it's reacting.
So if
Alright.
anything, that would be like a change in capacitance. But what's weird is that it's like I walk across the room and I punch at it, it has the same sort of reaction as if I'm close to it and I punch at it, and it's not like when I get close to it, it was like really increasing in its amplitude versus when I was far to
Right.
it. It was having the
But-
same sort of reaction.
It was same reaction, but the amplitude was less when you were further away, or the same.
No, like if I punched like this, it had the same exact reaction if I was close to it
so-
or across my room.
Oh, really? Still reacted like that?
Yeah.
So that means you have direct interaction with the ether.
Yeah, so I think it's like kind of like gravitational waves or something like that, or scalar.
Yeah, it could be scalar or electromagnetic waves that, like slices of an onion as it goes out from that location. So if you're influencing it with your arm punching at it, it changes the form, I guess, of the actual magnetic wave, and it doesn't matter what distance you're at. So it's almost like Eric Dollar was talking about scalar wave, where it's an instantaneous propagation. So if you shake one side, the other side shakes right away. Where in a Hertzian, it would be a wave like this. But when you take the two wires, and actually in the video with Chris Carson and Dollar, they show a demonstration of holding a rope, where scalar, if there's an interaction, it's instantaneous. There is no time. There is no time factor. So Yeah, it's possible. Maybe a scalar, you're influencing a scalar potential between the coil of your setup and your hand.
I think it's a primitive form of a scalar interferometer that I kind of figured out was working
Stumbled.
before I even knew what
Stumbled on.
that was, you know?
And you know what? That device could be useful if you're working with other devices. You could see, movement of the scalar potential using your device. You can detect it. It's like you've created an amp meter or a multimeter, but for scalar waves.
Yeah, and like the O-scope, it only picks up on the energy type it's designed for, and not the negative energy time reverse wave. So, like when I was doing my DeFi oscillator experiment, kind of like a cold fusion setup, it was not able to measure things really. Like it would just blip out into a single dot in the center of the
Yeah,
screen or just
good.
nothing at
Yeah,
all. And so maybe I didn't try using it, but
yeah.
because it was in the garage. But once I have a place again, I'll try measuring like a water cell, a cold fusion reactor with one of those and see what I pick up.
Hey, Philip, you could use this device for your tractor beam because that device he made would be able to detect your experiments if you're doing, your laser tracking system.
Yeah, and you need to be able to modulate the energy density. Um,
No, but this
using
would pick it up. I'm saying his device, what he made, would be able to confirm your results. Now you can
uh,
test it using what he's using because obviously it is a form of scalar wave that you're creating for
yeah,
your tractor beam.
yeah. I need to take a look at
Yeah, like Elijah, maybe he can draw up a little schematic and send it to me, and then I can send it to you, to your email, Philip, and then you can take a look at it and see what he was doing.
yeah,
Uh, and that might be an instrument of measurement to test your ideas out. Because it's one thing to make a device and trying to see what the results are, but if you're not using the right meter or the right tool to take measurement on, multimeters weren't designed to detect cold energy. They're not designed for that. You have to use other methods to try to figure out what your results are. And I'm sorry, multimeters are probably one thing that will never work. You might probably get a little bit more insight by using, say, an oscilloscope, because you'll be able to see the waveform and where the spikes are going, major negative spikes versus positive spikes. You'll get more information using a device like that versus over a multimeter, because the multimeter isn't really designed to pick up cold electricity. So,
yeah,
food for thought. So, yeah, it's one thing is to come up with detection devices, and I think Elijah, you might have came up with a very good one. I would really try to make another one, make it a little bit more refined, a little bit more, you know, time to wrap those coils good, and make it more uniform. Because I really think you got something there.
Yeah. I would have to look at the video of like how I set that one up, because I set it up. I did so many experiments with that Meg, so I would have to refer back to the video. But I think I was not pulse width modulating the center coil, and I think I was using the center coil as a the point of measurement on the Arduino and printing that
Right.
out with code onto my screen in a graph. And
Right.
I think that I was
Yeah, I
using
see what you're
basically the two large coils on either side as a pickup coil, and
Right.
I had them basically,
Picking up the signal from the coil in the middle, the small one.
yeah. So if
Yeah.
these are the 2 points of the Meg,
Right.
that the U shape, I had one wound like this, for example, and the other wound like that to where like the wires flowed together through the center
Okay.
of the
So
U.
one clockwise, one counterclockwise.
Yeah, basically. And then you would get two, or I would have to look at it, but basically I went diagonally across it to wire from one to the other. So
Yeah.
that it was basically going like this and then to the other and then like that. And then you'd have your
Yeah.
two output ones. And I think I just had them freestanding like that when I was measuring.
Okay. That's cool. Yeah, Philip, I'd be all over this one. That's something you're going to need to detect your results.
Yeah, thanks, Elia. I'm looking forward to check it out.
Yeah, maybe you can in the next week when he's got free time, he can drop a little schematic what he did, and then I can relay it back to you, or if you guys want to exchange in the private chat your email addresses, and you can correspond with each other. I
Yeah,
got.
we're already connected on Facebook.
Oh, okay, so that's good. Yeah,
Yeah.
yeah, that's right.
I'll try to track down that video and just kind of send that video link and review what I did and try to put it on paper a little bit.
Cool,
Yeah.
thanks.
Now, if you were to say modulate that middle coil, the small one that's in the middle of the two big ones, if you hook that up to, say, a signal generator and start modulating it, and then put it near something that you know it's going to emit, a potential difference on those coils, you might even be able to get a better, more stronger signal when you send it through the Arduino to put it on a graph, like just to give it a little bit of an energy boost to polarize it a bit so that signal is stronger. You know what I mean? I don't know if that makes any sense. I'm just trying to come up with ideas that way.
It makes sense. The Arduino is limited in what kind of voltages and current it can handle. So
Right.
that's the reason why I didn't really pump a bunch of energy through it. But
Right.
that is
Doesn't have to
also
be
the
much.
reason why I did the 5-day run experiment, realizing that you can tickle that center coil. So I
Right.
actually connected the center coil to part of the wires coming out of the generator coil from the Bendini motor.
Right.
And then you guys can watch the video on it if you want. But
yeah, as soon as you change the frequency form as soon as you change the frequency form of the potential going through a Bedini motor, you can make it run for weeks. Like, like I could take a 5 or 6 9-volt batteries, hook them up in series, and my motor would run for months without running out of power. So all in the switching, and the switching is the key.
Did you notice a change in the way the motor was running cyclically throughout each day? Because I was noticing at like around 4:30, 4:20 in the morning or so was where it really slowed down every single day. And this was mid-September. But then around 10, 11 a.m., it was picking up and it was just flying.
Yeah, that's right. At nighttime, it will slow down because of the lack of, obviously the UV and photons coming from the sun, which actually has interaction with the core while it's running through the daytime. There is definitely a difference. Now, you'll also notice a difference too, is if you have a full moon. I got good results on a full moon versus a night that the moon's not visible. So I do believe there is a photon interaction from either the sun or the moon during those time periods. But yeah, if there's no moon at nighttime, your system's going to lose a little bit of power. Even through an eclipse, solar flares tend to either do one of two things: make my motor go crazy or not work at all. Like to the point where it just won't function. It won't work. Like I was like, what the hell is something wrong with my wiring here? And as soon as the solar event was over, then mysteriously my motor decides to work again. So this happened a number of times, not just once. It happened a number of times. So
Probably same with thunderstorm or just like a thunderstorm or a bunch of wind even. Like I've noticed that wind will affect certain experiments. When it's windy outside, I just get a bunch of sparks, and then when there's like no wind, it's completely different. It's like barely anything at all. Does that happen
yeah,
with your motor too?
yeah, it does. Yeah. So yeah, some interesting effects. Like even on my body too. There's some nights that I was working late on it, and you would think, late at night you get tired and you want to go to bed. For some reason, I felt like I just woke up from an 8 hour sleep. I wasn't tired at all for some reason. It was really weird. Or if I wasn't feeling good that day and I turned the motor on, I'd start feeling better. I don't know why. It's just a phenomenon I've noticed. And there's another YouTuber out there that's working on a Bendini motor right now. And he was actually talking about this same thing I'm talking about right now earlier today. And I found that kind of funny because I had that effect happen 2.5 years, 3 years before he even started talking about it. So I'm not the only person that's seeing this effect. And there is an interaction with the magnetic radiation off these motors. Like Tesla was working with it back in the 1920s using the one-wire circuit and basically putting it through a spark gap and having physical contact with the spark gap. He was, doing some healing stuff with the stuff. And then finally, make a long story short, around 1935, when the FDA came around and the big pharma started getting their foothold in America, they basically banned all of Tesla's body healing devices. They were banned. They were taken off the market. This was not allowed anymore. This was not acceptable by their science. So, Hutchison has one of Tesla's devices, and there's a guy, I believe he's in the UK. He's got about 5 or 6 of them, of these Tesla healing devices. So, interesting stuff.
Well, I definitely attest to everything you're saying because I had basically a bunch of spider bites on my left foot from cleaning out a guy's woodshed. And little did I know at the time because it bit me through my shoe. But long story short, it was a flesh-eating venom. So the flesh started falling off my foot and it wouldn't heal for years. And so when I did this DeFi oscillator experiment, I started running an LED into the water and then grounding out into like a phi spiral coil into the concrete, into the earth. And basically within like 2 weeks, all the skin had regrown. And like my foot isn't like quite the same as it was before the spider bites, but now it's not like my flesh is falling off like it was before. And so it definitely did something. And then also another weird thing while I was doing that was I was like holding, I was connecting basically across an LED to a wire holding it and like shorting through my body to ground. And I was like, I should be getting shocked right now. Yeah. Why am I not getting shocked right now? And I thought, shock me. And I've never had this type of shock before, but my entire vision went just straight up green screen. And I just was sitting in my chair, so I didn't fall or anything. But my whole body just got shocked, and I thought I was dead. And then my vision came back after like probably 10 or so seconds. And I was perfectly fine. Like it didn't stop my heart. It didn't like jolt my body where I was like clenching like normal electricity. But it responded to my thoughts, and it wouldn't shock me otherwise until I told it to shock me.
You had to command it. See,
I had to command it, and then it did. And
see, there's some intelligence there. There's more to this. I'm just going to scoot for a quick smoke. You and Philip chat it up, and I'll be about 5 minutes, and I'll be right back.
For sure. No problem. But that's the moment that I realized, okay, the ether is conscious and plasmoids are conscious, and plasmoids make up the universe. So I just accepted it. And I've had
Who
some
was
other weird things happen. Like one time lightning bolts shot out from my fingertips when I was
yeah.
like doing an experiment. It was the experiment on, I put it on YouTube, but I have this skateboard deck on the ground and this partial section of a transformer core with like custom coils on it go into a cat bank into water cells. And somehow it charged my body and I went to bed that night and like lightning shot from my fingers like this far from my fingers to the phone into my cat when I went to go like pet my cat
Oh,
on my, and it wasn't just like one shock like how you slide down a slide and touch a doorknob. It was like bzzz, like Palpatine, like it was like
yeah.
oscillating, buzzing for like a good 2 seconds. It was crazy, and it was
Oh,
purple, and it didn't hurt at all. It felt good.
just like Lord Raiden in Mortal
Yeah,
Kombat, Yeah, that's cool.
not sure. I I don't know why, but it didn't hurt. It like felt good. So I think some forms of electricity can heal, and some can make you sick. Because
Yeah, it
I
was
played
coming
around
out
with
of your
MOSFET,
body. It
and
was
the
coming out of
MOSFETs made me feel sick.
yeah. It was coming out of your body. You didn't like receive it, so that's different. So that's not painful, I guess. But there
Well, when
was
I
somebody else who was talking about plasmoids. I forgot his name or her name. Um,
Malcolm Bendall maybe or Ben.
yeah, Ben maybe. I can't remember. Somebody was talking about plasmoids. Um, but yeah, maybe. Sorry.
Oh, you're all good.
Yeah.
But I was saying it's not just when I was getting discharged that it felt good, but when I was doing that experiment from like a foot away, it shocked me and it didn't hurt at all. And it was the same purple lightning. And that was when it was, I guess, charging me. And it shocked me from the water in the jar. So I had water inside of a glass mason jar, like probably a quart full. It was acting like a capacitor. And I guess it got charged enough to spark across like a foot gap or so.
You were like an electrode, something like
Yeah, like a capacitor discharge almost.
that. Yeah.
But that kind of felt the same way. Like it surprised me, but it didn't hurt me.
Yeah. Yeah. Cool. Um, well, if the voltage is high and the amps is low, then you're good.
Exactly. So
Yeah.
I think that's also a key to over unity is keeping the current low because you have a fast rate of the dipole switching. So you get the displacement current density, and the displacement current density goes through your body so efficiently that the current can't kill you.
Yeah.
So it's safe, but it's also efficient.
Efficient, you mean it creates a greater energy potential?
Efficient, like you don't have the heat loss from
Oh, okay.
conventional.
Yeah. Yeah.
So you're basically using the energy through the field structure that is flowing, being structured from the wires and the oscillation, but it's not flowing um, around the wire as much with that magnetic current, like turning around the wire. It's I don't know actually how it's flowing, but I know that it's different to where you don't have that heating up effect. If anything, it'll get cold.
Yeah.
That's how you know it's doing good, if it gets cold.
Yeah. Yeah.
Like the transistor on the Bendini motor I had when I was doing the D-Phi oscillator experiment got cold. And then also when I was doing the 5-day run experiment with the Meg connected to the Bendini motor, my whole room would get cold.
But that has to do with the energy density. I know the temperature is proportional to the energy density, but I forgot if it's colder when the energy density is denser or the opposite. Um, but I know there's a relation there.
Like, are you talking energy density of space through like black body radiation, or are you talking like energy density of the gas, or
Well, the overall energy density, um, well, whatever sums up, whatever sums up in the area, like magnetic, electric, gravito-electric, or things in motion, the kinetic energy, and all that.
right? So
It all sums up. So, but it's gonna affect the temperature. But I forgot if it's gonna get colder if it's denser or the opposite. You would think it gets warmer when it's denser, but I'm not sure about that. I need to review that.
I think it's like a negative entropy situation versus an entropy situation. Like heat getting hotter is kind of more like your entropy situation, and getting colder is your negative entropy situation.
Yeah.
And I think the getting colder situation is making the energy density in the circuit get higher, but the surrounding environment getting lower, making a gradient.
Oh
Whereas
yeah.
overall, if you drew a box around like a gas, right, the hotter
Yeah.
gas is always going to have a higher energy density because it
Yeah.
has higher temperature, it's emitting higher frequency light, it has more kinetic energy, and so
Yeah.
on and so forth.
Yeah. You're right. Yeah.
But I guess it depends on how you look at it, because you could look at the energy density of the mass itself, right? E equals mc squared is part of the equation, not the whole equation, but for at least rest mass, like gases in a box, a hotter gas would be less dense potentially, unless you force the same amount of molecules in the box. So there's less
Yeah.
molecules, there's less energy overall, right? So
Yeah.
it just depends on how you look at it. Like how do you draw that Gaussian surface, right?
Yeah. Yeah. Exactly. Um, but yeah, you're right. You're right that the if the temperature if it's denser, but at some place, but there's a gradient, then it's gonna get colder outside. Um, yeah, so there's probably something like that you had. That's what I would guess.
Even like say like a battery, electrochemical battery. Bandini did some experiments where he was putting the cold electricity into the battery, and then he would take one of those neon bulbs, and he would connect one terminal to the positive terminal of the battery, and then he would ground it to the case of the battery, and the light goes on. So it takes 90 volts to light up one of those, those little neon bulbs. So definitely the electrochemistry of a battery starts creating a field within itself. It's polarized, and that's what the cold electricity does to those batteries. The big standard car batteries. When you start playing with cold electricity in those, the chemistry has a big part in that polarization of the negative energy. It actually
I don't
emits
know. Sorry. Go ahead.
it actually emits a field. It creates a field around the battery itself. So, is it a heavy side component being created within the battery? Could be. It shows evidence of that. So, it's in the energy from the vacuum series when Benini's working with the monopole motor, and he shows that discharge coming off the battery, which I found quite interesting. So,
So top of the case of the battery, is it like a plastic or is it like a?
Plastic,
Yeah.
complete dielectric.
But he takes a wire off.
Yeah, one wire from the positive terminal from the neon bulb,
Mm-hmm.
hooks that up to the positive terminal, and then he just grounds it to the case of the battery, and it lights up.
But only when the Bendini motor is running, or even when it's off.
Running. No, I'm not sure about that. That's a good question. He did it while the motor was running. That I do know. Now, I've had experiments where I had my electromagnetic detector, the little beeper, and I would run my motor, and then after I stopped the motor, my battery would still be pulsating. It had residual pulsation for probably a couple of minutes before it died off.
Yeah, from my experience, they'll keep ringing like a bell for hours.
Yeah. I definitely detected that with my Renegade when I was running it on a car battery, or just those power pack batteries they use for UPS machines. And yeah, that battery was ringing after I shut my motor off. It was still ringing. So I found that quite interesting.
Yeah,
I wonder if I
bad
would do. Actually, you know what I'm going to do this weekend, Elijah, with my power cell? I'm going to hook it up to my my Renegade. I want to see how this battery reacts to the power going through it. I have a feeling there's something there that might actually help the device.
And if you have multiple power cells, I would try basically. So if there's a sandwich like this,
in series,
take another sandwich somewhere if you have another identical one, and see if you can like put it at an angle to where the two axes of the sandwiches connect at a point, and then take a third cell and walk around your room in that region where they kind of connect, and see if you can measure a difference in voltage across the room. Because if you can, maybe it's optically coupling either with the infrared light or more like a scalar interferometer like we've been talking about. And that could give you some interesting information. Maybe it does nothing, and that would be valuable too. But maybe it does something, and that would kind of tell you what's going on a little bit better.
It'd be like emitting like a frequency like a radar would. And then if you come in its proximity, it alters.
Yeah, and you'd be picking up the constructive and destructive fields, and where they collide, those two beams, you should have a higher energy density, and you could wirelessly pick that up in a third one probably.
Interesting.
So you'd have to make sure the temperature of your hand isn't affecting the experiment as a Peltier cell. So you'd have to hold it with like tongs with like a rubber glove on, so you're like isolated from it.
Plastic pair of tongs.
Yeah, something. But just a thought that might do something interesting.
Yeah, actually, I got those cells that I built. I built 8 of them.
What's the efficiency of solar panels? It's like 30%, something like that.
Yeah, they won't allow solar cells to exceed 21%.
21.
Yeah, there was a guy made a solar cell back in the 70s that was 98%.
Oh yeah.
He was pretty much disposed of, so to speak. Yeah. So I got.
Well, it depends on the type of cell. So if you have polycrystalline, it'll be a lot lower efficiency because of the grain boundaries. So it'll be like 7 to maybe 13%. But monocrystalline is a higher efficiency because it doesn't have the grain boundaries.
Yeah.
And then you have thermophotovoltaic, which uses the infrared light. But those are around 40% efficient with that spectrum of light. You're not accessing as much of the spectrum as a monocrystalline, which is actually tapping the infrared light as well.
Okay.
Yeah,
but
just to give you Sorry. Yeah. Here's my new cell. You can see how thin it is. That's how thin I got the layers. Like it's
Nice.
literally like 1 millimeter thick.
So you can stack them up and stuff.
Oh yeah, like I got 8 of them here. There's 8 cells.
Nice.
I wonder if you're picking up the Wi-Fi. Like, might be good to try turning off your Wi-Fi router too, because those
Yeah.
are millimeter waves, and that width is the band gap of Wi-Fi and the 5G. So if you get like metal mesh that's, or even an aluminum foil box, or even wet paper towels can block a lot of those microwaves, you know, if they're really saturated, and that could help isolate some of the noise from the environment to figure out, you know, are we tapping microwaves, 5G, that sort of stuff, or
Right.
is it something more exotic, or, you know, what's going on? Is it
Yeah.
a photovoltaic, basically? Like, I think it's a combination of things going on.
Yep. Could be. Yep. It's picking it up. Yeah, these cells are like super thin. They're really good. There's a couple of changes I want to do to them, but other than that, this is pretty amazing what I got going right now. Yeah. Yeah, getting consistent 2.5 amps current coming off these things. I've had spikes as high as 10 amps. That's like 3 cells together.
What voltage?
Anywhere from 2.5 to 4 volts.
Oh, that's good. So you have 20 watts.
Yeah.
How long does it last?
I could run an LED light that draws 20 milliamps at 3 volts for 2 days.
Nice.
And that's with a 30-second charge. So
you could kind of alternate between battery packs, use one while charging the other one, and things like that.
well, I was thinking of hooking up to the Renegade and actually have the Renegade charge them as it's running, like it cycles.
Yeah.
So I'd run a few minutes using the cells and then using the back EMF spikes from the Renegade and pump the energy back into the cells for like 30 seconds and then shut it off and then let the cells continue to do its job. It could be an infinite running, infinite power system that would keep the Renegade running pretty much indefinitely, because it takes such little time to charge them, and I can get so much out of it for a long duration, right?
Yeah.
So
Are you still serious about starting a business on that, or?
Yeah, I might even take it to one of the universities and have them evaluate what I've made.
Yeah, but you have to make them sign an NDA.
Yeah. Oh, yeah. Most definitely.
Because at the university, there's the first place they're going to plagiarize everything you did.
Yeah. Yeah, exactly.
If your windows are cold and you keep it kind of warmer inside or something like that, I would even try putting it up against the window so one side is cold and then the other side is warm, and see if that, see if that extends that runtime, and that would kind of deduce, like, is it infrared light? Is it Peltier? Is it thermal photovoltaic? Are we doing something more like a asymmetrical light cavity tunneling electrons from the 0 point? Because right now the possibilities of what's going on are like really big. Like, it could be a lot of things, and a little bit of testing, I feel like, could like really pay dividends to deduce what's going on, which would help you develop your cell, but also like you could potentially change designs off of that, or components or whatever, to target certain band gaps or temperatures regimes or whatever, you know?
Mhm. Yeah, getting some pretty good results on these cells. So every time I make a new cell, I'm like going up a notch, you know? Like this little stack here, I'm getting over 2 amps already, and it's been sitting for a couple of days. Yeah, 2.2 amps,
Yeah,
2.5 amps.
that's not like a normal capacitor. Some capacitors will like hold charge for a while like that, but most of the time they do not, you know?
Like eventually these do run down. They do,
Mhm.
but they take quite a while. Like, this cell here has been sitting like 3 days with nothing, and I'm still getting 2.5 amps out of it. So,
The weird thing about the 2-day thing that you're talking about is in cold fusion experiments where you make these solitons that can get impregnated into a material that make these radioactive isotopes that give off energy, they last for about 2 days.
yeah, yeah, that's pretty incredible.
So it could be a low energy nuclear reaction thing going on every time you charge that thing.
Yeah, something's happening. Still trying to make light of all this. Yeah, I should give it a little flash charge and see what I get because they've been sitting for a while. Do that right now while we're doing the show.
Does it change how it behaves if you like charge it by sparking something to it versus if you just connect
Yeah,
the
it
terminal to a
likes.
battery?
No, you could do it dead short with a battery to it, or you could spark it. It seems to like the sparking. I find.
Yep.
Um, don't know why, but it seems to. That's why I'm saying it might be a good candidate to run it with my Renegade because it's using negative energy spikes. So
So if it likes the sparking more, that's kind of an indication that it's making these solitons, right?
mhm.
Because that's how the Martin Fleischmann Memorial Project is making these plasmoids that they're seeing on the material. Like if you had someone with a scanning electron microscope, you would be able, or even sent one of these samples to Bob Greenyer, which I'm sure he would be happy to take. You could see like what's going on, and you could send him a couple samples. One where you spark discharge into it to charge it, and one where you just dead short it. See if the sparking and the discharge is what's causing the energy solitons, or if it happens every single time, no matter what. But one is more preferential, you know.
Okay, so I got 3 cells stacked. I just gave it a quick charge here. And I noticed too, when I squeeze the cells together, my potentials go up. So there's stack here.
By the way, it's out of topic, but I learned a lot on the NVDA Jetson boards recently, so I know how to optimize it down to the maximum GPU speed and how to manage the energy peaks that it creates sometimes. So it's pretty amazing. Um, I'm getting paid like a student, but a student graduating school. But what I do is pretty interesting. Um, they have talking about NVDA. Apparently, they have quantum NVDA NVQ link, something like that. They're working with quantum processors now these days. That's
Yeah.
pretty killer.
Yeah, they've got a new quantum chip they're working on that's made of bismuth
Yeah,
that actually
exactly.
replace silicon.
Well, it won't replace silicon because silicon has its role, which will tap more of the visible light spectrum. But bismuth can be like a solar panel that works like inside without the visible light spectrum off of the infrared light spectrum. So a very thin bismuth layer can act like a solar panel almost, but using a different section of the light spectrum. And according to Rick Mueller, because of its diamagnetic properties, the most diamagnetic material, it has anti-gravity properties apparently. And I don't really know how that works, but
Cool.
I don't think there really is anti-gravity. I think there's just gravity control.
Yeah, gravity control or manipulation.
Anti-gravity is still propulsion. It's really easy to achieve. With
You keep saying that, but like, what makes it so easy? Is it doesn't cost a lot, or it's just the circuit is really simple, or like, what's easy
yeah,
about it?
both. It's very cheap and easy to do, and you just need the correct mathematics. And now I have the mathematics, but I can't. You would agree if you're very smart, so if I shared it with you, you would understand without me finishing the sentence. So, but it's being reviewed by DARPA right now, so I can't talk about it.
Can you say if Tom Bearden was right with the spin being non-2, at least?
Yeah, it has to do with the Lorentz force. That's what it is. Lorentz force is overlooked, but it's a lot more powerful than people think it is.
So let's say the B field of the Earth is vertical because we're tiny on the Earth, right? And we have an E field going across, let's say, then my propulsion would be either in this vector or that vector into the screen.
It's more complex than that, and you have the gravito-electric field that is gravity, which is another field that people neglect. We have a whole bunch of stack of fields, and you have the gravito-magnetic field that nobody talks about and never was really properly tested. So you have all these energy fields or gradients. And the Lorentz force is not it's not just it's more it occurs more frequently than we think it does. So that's all I can say. I can't tell you why, but it's so simple that I can't share it.
Okay. But it's more complex than just simple E field orthogonal to B fields, making
Yeah.
or third orthogonal vector Lorentz force.
It's more than that.
This was a 10-second church. Look
Nice.
how bright it is. That's
Nice.
a 10-second church. So I'm just gonna. So I'm gonna.
I'll make the calculations for the hoverboard and come back to you how much I need.
Yeah. So right now, well, these cells have been kind of sitting around for a while, so I'm still getting over a half an amp, 700 milliamps. Yeah, they'll probably wake up as soon as I start using them. I find these things like to go to sleep, and then when you start playing with them, it starts to absorb more and more, and then start pumping out more current. There you go. See, I got 1.5 amps there, 1.6 amps.
But you haven't charged it anymore.
No, a 10-second charge.
Yeah.
2 amps.
So you're just discharging it for a little bit longer and it warms up and then starts discharging more current.
Yeah, that's exactly what's happening. So right now it's like discharging about 2 amps. Yeah, as I keep playing with it, going on and off, start playing with them, get the energy moving through the cell, it actually starts gaining power. So
Is the current the only one that's increasing as you're doing that, or does the voltage also increase?
I don't have 2 meters hooked up, but let's here. Let me just check the voltage here.
Because voltage is coupled to frequency, and spatial energy is tied to that frequency. Higher frequency is higher spatial.
So I got 3.3 volts at 2 amps.
You said 3.3?
Yeah, 3.3 volts at 2 amps.
But it doesn't burn out the LED.
No.
See, conventional current would always burn that out. So that tells me it's displacement current density, but the meter is measuring the RMS current. So it's just averaging that out to 2 amps.
Yeah.
So it's definitely using displacement current density. Otherwise, that LED would not work. It would just fry out.
Yeah.
Well, even after it fried, it would still kind of work, honestly, but it wouldn't show
So,
light.
which also tells me too, this is not a traditional galvanic cell. There's no galvanic action happening here.
Right.
That makes my battery different than your standard battery that everybody else is making.
I definitely agree with that.
Yeah. Take my background off, then you can kind of see it better. Hold on.
It looks pretty powerful.
Look, like that. I haven't charged it since the last time I talked about it. Like it's holding like an incredible amount of power, and it'll run like this all night long, all night. Yeah, it's only drawing 20 milliamps, but there's no galvanic action happening here at all. None. It's
So
solid
maybe
state.
that current is oscillating back and forth like a parametric oscillator, building itself out, building that field, because it takes a while to build up, like you're saying. So it's acting like stacked harmonics, like you're on a swing, like a parametric oscillator, creating
it's back
displacement current density. So that allows for a high displacement current density, which won't fry the component, and it only whatever load there is will just take whatever is required, but no more than that.
It won't push it like galvanic. It would have burned this light out big time. Would have fried it. It's like it knows how much potential to pull out. So, yeah.
Yeah.
And I find if I push them together, it seems to run a little stronger when I put a little bit of pressure on it. So I think there is a quantum tunneling effect happening. Definitely no galvanic action happening at all in this because there is no liquid in it. It's entirely dry. So
what's the best way to extend it? Like it's already pretty much thin, like you just showed. But are there other ways to maximize it, or?
Well, you could run it with a standard capacitor. So when you want to draw current from it, it's going to pull it from the capacitor. So you're not going to put a stress on the cell. That's why when you build, like, say, off-to-grid power systems, they like to stack them with a stack of capacitors. So when it needs that current demand, it's not pulling right from the battery. Because you start drawing huge amount of current from a battery continuously all the time, you're going to kill the life of that battery. The battery won't last. It'll get sulfated and die off. That's 9 times out of 10 what happens to your car battery because you're pulling direct amps right from the battery. That is absolutely the worst thing to do. If actually, I've seen a few guys do it. They buy these, Maxwell super caps, 6 of them, and they'll hook them up directly to the battery. Okay. And then the high voltage leads that used to start and turn over the car, instead of attaching it to the battery, they hook it up to the capacitors. Because with a capacitor bank of that size, you could pull probably 1,000 amps out of it in 1 second, no problem. And it won't kill the battery off. It's a buffer. You're creating a buffer between the battery and the load with the capacitors. So,
but we know that this is operating differently. So I think like that, what your answer works for a galvanic system, but yours is
Right.
non-galvanic. So I think what you need to do is instead of just killing the dipole by looping through an LED and coming back, which slowly kills that dipole, isolate the dipole from the source through a transformer. So you basically isolate from the primary to the secondary, where your primary
Yeah.
on your
Yeah, I see
transformer
what you're
is
saying.
connected to your cell, and then your secondary coil has one wire freestanding, and then the other wire has basically two diodes off of every tap. So one would be pointing out and one would be pointing in at the same point on the wire. So one
Okay.
anode's attached and the other diode has a cathode attached. So that would be your voltage tap off your secondary that wouldn't kill your dipole. And if you
Right.
have more loads, you can do more of those points off of that secondary winding. So if
Now the
you
thing
need to make sure you have an extra long wire hanging off of it, and ideally you want to make it symmetrical. So like if you know that you have 10 inches hanging off one side, you have 10 inches hanging off the other side.
Right. Yeah. Makes sense. Now the thing is, I don't know if I could do it because the potential I'm working with is so low. It's only 3.5 volts. I would have to oscillate that power through a transformer. Actually, I got a DC to DC step-up transformer, and it has a little oscillator chip in it.
Those ZVS drivers, they're there's different ones, right? But there's AC ones and then there's DC ones where it's kind of acting like impulse to DC. And you can also use things like boost converters or voltage multipliers, simple voltage multipliers, so you don't have to compromise on the efficiency aspect so much.
How about just hook it up to a joule thief? How about just hook it up to
a joule thief is some sort of pulse width modulation, and it's very efficient, and it would sip it. But I don't think it would necessarily isolate the load from the source dipole is the problem. So you'd still need to isolate it through some sort of setup like I explained. There's probably more ways to isolate it, but that's the only way I know of isolating it, through a transformer like I described.
Yeah, you're right. I just got to get the voltage up, and then I would be able to put it through a transformer properly. When I'm working with such a small potential like this, it's kind of hard to do that. You know what I mean? Unless you have.
But I mean, you can stack those cells, right? So.
Oh yeah, yeah.
They act like a battery, parallel versus series, right?
Yep. I could do whatever I want. I could do both, series, parallel.
Yeah, so put them in series to increase the voltage till you get the voltage you want.
Yeah.
And that way you don't have the inefficiency of some sort of like boost converter, like an MT3806 or something, but you get the benefit of added capacitance without that efficiency loss of that middleman. And then you do your modified joule thief, let's say, with the custom transformer hooked up to it, so the secondary has your output, so it just sips off the dipole with the joule thief oscillating the primary of the transformer, and that would increase the current component in theory. So you initially started with a higher voltage component by stacking those cells, and then you slow down that magnetic field with that primary coil to increase the current, and then you just control the voltage on the output with however many windings you put. So you could step it up or down depending on what you want it to power.
Yeah.
But you still have a sort of reactive power component that you're using, but it's being converted to real power through the diodes.
Yeah, this diode switching.
Yeah, so that way it's acting kind of like a parametric oscillator. Since it's already acting like a parametric oscillator, you want to use that somehow. So maybe you can make it oscillate with an antenna. You can find certain resonance depending on the layer thickness and the geometry of your cell. And you might be able to make it self-oscillate and keep oscillating and input more energy, like an AM radio picks up amplitude.
Yeah, like an antenna. Yeah.
And that might be a simpler route to go, but it might be at the compromise of taking up a little space. But that
Yeah.
would be maybe less components and more direct way to get there through hardware, for example.
Yeah. So many ideas. It's like, oh my God.
Right.
I want to do all of them. So many
Yeah.
ideas, enough time.
I feel, yeah. I work a lot, anywhere from like 40 to 60 hours a week. So
Yeah.
I'm finally
well,
out of debt, saving money for land, kind of have
yeah.
all my research on hold until I get land.
It's
Yeah.
hard. It's hard to, I started my business and things like that, but I had like 50 grand in my. I saved like 50 grand and I burned it all on my business initially because it's hard to when you don't know anything. It's hard to get fooled by marketing agents and all that garbage that they try to screw you all the time.
Yeah.
And it's hard to keep the discipline, for entrepreneurship. So yeah, be careful for that. So, but in your case, it's more about experimentation, which is good. But entrepreneurship, you want at the same time you want something, you want money, like you deserve money and things like that for your hard work, but it doesn't work that way. People. So you try to speed things up by hiring fake marketing agents, but the real thing you have to do is to spend your time having a perfect product before selling anything. So it might take 20 years, 30 years, doesn't matter, as long as your product is good enough that you can sell. So that's the way it is in entrepreneurship. But yeah, I'm just saying, like, be careful, So
Yeah. Yeah.
I will
Brendan
definitely
said,
be careful.
don't
because
sell your soul, Phil.
what's that?
Don't sell your soul.
Yeah, something like that. Yeah.
it's like when you're poor, you can't really afford to mess up so much. And so you have to be careful. And then also it kind of forces you to have a certain advantage where you find almost better solutions to things because you have to when you're poor. Because you
Yeah,
have less
exactly. My
resources almost.
the director of my incubator in Montreal, he said, um, entrepreneurs that are constantly broken are more likely to succeed because they find more efficient solutions all the time, and cost-effective solutions constantly. So they're more likely to succeed. So that's good news.
And the good news also is that we don't necessarily have to sell a product at first because we already have the nation states who have built the infrastructure for us to sell the electricity to them, right?
Yeah,
So
and
phase locking microinverters already exist, and there's a lot of cheap renewables out there that people just don't know what to do with that you can get now. So you can get some return on investment on the land, get yourself established, backfeeding to the grid with a permit, do everything ground mounted so you can do it yourself without permitting or extra stuff. And then from there, you sneakily inject alternative energy and then run that through something more conventional like a phase locking microinverter, right? So then you're basically doing your research while simultaneously getting a return on investment while developing the prototype, which is the product, the end goal product, and you're going to know exactly how well it works because you're actually using it.
Yeah, and there's a lot of. Originally, I thought that venture capital was the way to go and all that, but first thing, they're extremely difficult to convince. So you gotta waste a lot of time on that. And second, it's a lot better to partner up than to have VCs. And third, there's a lot of grants out there, especially in the AI time. They are hybrid services that uses AI to prepare the grant proposal you submit, which is 5% of the cost of human-based services. So now's the time to apply for grants. We cannot complain. It's back in when I was at university. That was back in 1996. That was right after the internet was invented and the browser, the Netscape browser, and all that. So I studied all the classes that I skipped that I didn't go on the internet because I didn't even have enough money to buy the books. So I was going on the internet, more likely on the MIT website. And now there's AI to do all the administration bullshit. So I cannot complain. There's that AI boom. So I cannot complain. There was that internet boom, now the AI boom. So everything is there. We just have to see it.
Yeah, good point. Yeah, it takes a while to get yourself set up though to even start to use those tools though.
Yeah, but most of the people, they see negative things all the time, but there's a lot of positive things that people don't see, and that those are the most important positive things that I notice. So if it wasn't from AI, it saves all the market analysis bullshit, and how to search for emails if you want to contact somebody, things like that. It helps a lot. So it's not necessarily people use it to make their mathematical, to work out the mathematics and things like that, but it should be used the other way around to do like probability statistics compilation. Use it to replace lawyers. You use it to replace all the administration things. We need to use it the other way around.
Hey, Elijah, I got a quick question for you. I got these solar cells. They're supposed to be coming in tomorrow. They put out 2 volts at 160 milliamps. Do you think I could run that with the power cells here and actually have them like charge, keep like a charge going in them? Or
Yeah, I definitely think as long as there's visible and infrared light, there should be some power coming out of it. They're monocrystalline, I assume, or
yeah, they're
polycrystalline?
monocrystalline. Yeah.
Okay, yeah, the monocrystalline panels, they access the infrared light and a lot of the visible spectrum as well.
Right.
Anything longer in wavelength than your infrared light, you're not going to be able to tap with those types of cells.
Right. So if I hook them up,
yeah,
so
in
if I hook them up, get a better charge, you think, or
it would keep the dipole alive up to the smallest voltage in your string. So basically, if you have one little solar panel or cell that's outputs, let's say max power, working power 2 volts, not open circuit voltage, for simplicity, then it would keep that dipole in your non-galvanic cell charged up to 2 volts as long as there's enough sunlight, right? So that would probably extend your runtime by an additional day, I would assume, easily.
Yeah. What's that buzzing noise?
Sorry, someone called my phone. I'm on my phone.
Oh, okay.
Yeah.
Can you share my screen, Mike?
Yeah.
check this out. It's pretty cool. There's a startup. I think it's in Oregon. They 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 have AI data center that are floating on the ocean, and not only it cools down the data center, but they use the energy of the waves to power it up. So it's kind of self-sufficient. It's pretty amazing, you know. Wave-powered floating data centers are emerging as one of AI's most unconventional infrastructure experiments, as a Pantalalas project attracts millions. So so yeah, it's pretty cool.
So many.
And
Those are like
another
truck-
thing they could be using that they're really not using so good is tidal power. So tidal
Yeah.
power is kind of restricted where you can use it, because you have to have like an inlet of water that's kind of U-shaped. But you basically just make a hydroelectric dam to where you let it fill in. It flows one way, so you have the generation, and then you let it flow out, and it flows the other way, the turbine. And so you
Yeah.
get it as long as there's a difference in water level, which there is pretty much all the time. It works best where the tides swing a lot, like in Alaska, and not as much, obviously, towards the equator. But,
Yeah.
they should really
Probably the
be
Bay of-
trying to
probably
find
the Bay-
spots.
The best place would be Bay of Fundy. Yeah, the Bay of Fundy would be the best for tidal type currents.
Oh yeah. Where's that?
That's in right off the coast of New Brunswick.
Oh, okay. I think your friend is getting angry, Elijah.
Maybe it's a girlfriend. Who knows? Yeah, my anniversary is coming up soon. July
Is it
24th.
24th?
Yeah, it's coming up. Yeah.
So you'll be
Yeah, sorry,
50, is that it? Sorry, you'll be 55?
What, excuse me? I'm only 53.
53, okay. You'll be 54?
Yeah.
Yeah.
Yeah, I'll be 54 next year. Don't
Yeah.
rush it. Yeah. 17 years of marriage. Been together 20 years. Yeah.
You still have, that's just half of the life. You still have another half.
Yeah, hopefully I get another 30 years out of me. I'm hoping 30 years.
Yeah.
My dad's
But-
85 now, so
I'm pretty sure they're gonna find a solution to rejuvenate.
yeah.
Rejuvenate.
There's a really good not Danny Jones, it's the other guy, what's his name? He did a show with a microbiologist, and you'll probably see it in your search if you look for it. They're talking about how important the mitochondria are in your body. They are the energy transfer device of your body. So you have about, I think it was 100 million mitochondria per cell. So your
That's
body
crazy.
has 500 billion trillion cells in your body.
6
So-
trillion plus.
Yeah, each cell has something like 100 million mitochondria. So the mitochondria, what they do is they take the food that you eat and it converts it into a photon, and that photon creates an electromagnetic discharge current. And that discharge current is what powers your body. This is the mechanism that actually powers your body. So there's a
Interesting.
photon component, there's a photon component, an electro component. And that electrical discharge powers your cells in your body, every single cell in your body.
I guess it was more efficient 30 years ago than it is right now in my body.
This guy is like a PhD in mitochondria, specifically in mitochondria. It's a really good watch. It's on YouTube. Not Danny Jones. It's this other dude. Hold on. Let's see if I can find it here. It's like a 2-hour show. Let's see if I can find it.
I think I read a study somewhere where if you intermittent fast and fast more regularly, the energy density per mitochondria goes up.
Yes, because what happens is in most cases, what he was saying is if you have too much food going into your body, the mitochondria cannot process that amount of energy coming into the system. It's like trying to squeeze a huge amount of food through a tiny little tube. It bottlenecks. So the mitochondria get backed up. They can't process that energy. So it leads to a whole bunch of different diseases like diabetes is a huge one, type 2. He talks about this in the interview. He's a PhD doctor. And it was quite fascinating. I'm saying, well, how about if I were to make a biological battery using mitochondria and actually make a power cell that's actually physically alive, like a living organism that creates electrical power? Now, that would be cool.
I think we kind of are. I've done experiments with
No,
my
well,
own
we
body.
are.
I'm
Well, we
convinced
are
the
better.
human body is over unity with how much I've eaten at times versus how well I was able to function. Like most of our energy is coming out through thermodynamics and that sort of regulation of homeostasis. But if you do the math and you intermittent fast a lot and you barely eat anything, you just get your minimal nutritional intake. It's crazy. It's like, how am I still alive?
Yeah.
And I didn't just do it for a while. I did it for like months.
Yeah. Well, what I
got
do,
skinny,
like
but still.
what I do is like micro fast. So I'll have my last dinner, say around 6 p.m. every day. And then I don't eat any solid food until noon the next day. So I got all these hours between 6 p.m. at night till noon the next day where I'm not eating any solid food. I might have like a coffee or whatever in the morning, but that's about it. I don't eat any solid foods after that. Like Friday night tonight, yeah, I'm eating my peanuts, whatever. I'm going to have a cheat day, right? But I've noticed a big difference how I feel just doing these little micro fasting, and it cleans out your liver. Like if you keep your liver cleaned out, then you're going to feel that much better, and your body's able to process food better, right? So I pretty much do it, 5-6 days a week. I do this. My last meal at 6, and I don't eat till the noon the next day, and it does make a difference. It makes you feel better.
Yeah.
And cinnamon will help clean your liver too.
Oh yeah, cinnamon. Cinnamon's a big one. A big one.
And my
All these
favorite
doctors talk about.
my favorite one is coffee. It's anti-cancer. It helps.
I've heard that too.
Yeah.
I've heard that too many times. Coffee has a huge amount of benefits. Like me, I'm a coffee connoisseur. Man. I have 2 to 3 coffees every day, and yeah.
I'm not gonna get cancer in the next 500 years. That's for sure.
Yeah. I'll be happy if I make it to 85. That's all I gotta say. If I make it as old as my father has, I've done my. Right?
Did you know that people like Chuck Norris, he trained so hard that he overtrained, and his life expectancy was 76, but he lived until all the way to 86. But people who train at his level, it's kind of overtraining,
Well, look what happened to Bruce Lee. Same thing.
Yeah.
He killed himself by overtraining. Like you just went way overboard.
But Bruce Lee is like me, but physically he hated wasting a day not training. Well, it's the same thing with me. I hate wasting my time not doing physics or computer science or stuff like that, because I don't like to waste my time, But it's the same thing with Bruce Lee, but physically, he hated not training.
Yeah. Yeah, it becomes part of your daily regimen, and you kind of feel weird if you don't do it, right?
Yeah.
Yeah. Anyways, guys, we're gonna square up. We just gone past the 2 hour limit, but anyways, we go live to air every Friday night. Every Friday, 9 o'clock Eastern, 6 o'clock Pacific. Don't forget to check out the Faraday Research YouTube channel. If you're haven't subscribed to the channel, please do so. It's only $3.99 a month, and you get access to well over 1,000 videos, well over 1,000 hours of live shows like this one we just did tonight. Excellent content for you, hours and hours. It would take you months, probably a year, to get through all the stuff that I have on my channel. And $3.99 a month is a pretty good deal. So I would do that and help support the channel. Elijah, thanks a lot for jumping on. Hopefully, we'll see Lulu next week. I know she had some family stuff to take care of, and hopefully, she'll be back next week. Philip, thanks for your presentation. Everybody, have a great weekend. Have a happy 4th of July, and we'll see everybody next week.
Cheers.
Take care. Elijah, stay on after the show, please.